Real-world linear functions. So talking about linear functions, function meaning we have an input and an output. Each input only has one output. We're going to look at linear functions where they make a line. We've looked at those before, but let's look at some real-world ones. So the table shows the number y of calories you burn in x hours of jogging. Write a linear function that relates y to x. Interpret the slope and the y-intercept. So here's our table. We're going to write a linear function. It's linear, so we know that it's going to be set up as y equals mx plus b. So I need to find my slope. I need to find my y-intercept here. So I'm going to find my slope by doing y2 minus y1 over x2 minus x1. So I can use any two ordered pairs from this table. I just chose the first two, and I came up with a slope of 400. So now that I have a slope of 400, I need to go back and find the y-intercept. Now the y-intercept is not in this table, so I'm going to need to do some algebra to find the y-intercept. So again, flashing back to chapter 4, I'm going to take my equation, and it starts to look like this. Y equals 400x plus b. Now I'm going to use an x and a y from my table. I picked the first ordered pair here. I picked 2 for x and 800 for y. So I plugged in 800 for y equals 400, and then I used my 2 for x plus b. I'm going to do my algebra here to isolate the b. So I end up with 800 equals 800 plus b. Subtract 400 on both sides. B is equal to 0. So my equation looks like y equals 400x plus 0 gives me just a y equals 400x. I don't really need to worry about the plus 0 at the end of that. So here's my equation, y equals 400x, or y equals 400x plus 0. They want us to interpret the slope and the y-intercept. So my slope, which is 400, and remember slope is y over x, so my 400 is calories burned per hour. So I burn 400 calories every hour of jogging. My y-intercept, we got 0 for an intercept for y-intercept, so that means 0 of an input, 0 of an output, which makes sense. If you have 0 hours that are spent jogging, no calories will be burned. So 0 hours, 0 calories. That makes total sense if we think about what the real-world interpretation of this table means. Next, they want us to graph the linear function. So we have a coordinate plane over there. We need to set up our coordinate plane. We need intervals that make sense here. So these are the ordered pairs I want to graph on there. So I want to make sure they fit. Mine do not fit. So let's write those, set up those intervals so we can fit everything on there. We also want labels. So my x-axis, which is my independent variable, we're going to do hours. My y-axis, which is my output, my dependent variable, is calories. And then I'm going to write those ordered pairs. I did include my y-intercept of 0, 0 on there, and that's what my line looks like. They also want to know how many calories do you burn in 150 minutes. So notice that my table here is hours, and they've just talked to me about minutes. So I need to kind of convert there. So I took my 150 minutes and converted that into hours, because I divided by 60 to break it up into groups of 60. So I ended up, that's 2.5 hours. So I plugged 2.5 into my equation, and I came up with 1,000 calories. So in 150 minutes, I'll be burning 1,000 calories. So interpreting those pieces from our equation and our real-world situation. All right, let's look at one more real-world situation. Your earnings y in dollars for working x hours are represented by the function y equals 6x plus 12. The table shows the earnings of your friend. So we have a table for our friend, and we have an equation for us. Remember, we should be able to, when we're working with relations or functions, we should be able to go from a table to ordered pairs to a mapping to an equation to a graph. All of those things I should be able to go from one to the other. They're just comparing different patterns. That's all they're doing. All right, so the question, who has the higher hourly wage? So for you, we're looking at y equals 6x plus 12. Since my y is dollars and my x are hours, we know that our slope represents dollars per hour. So I know that my slope will tell me what I'm earning per hour. So in this equation, 6 is my slope, since it's what's next to the x. So it's $6 per hour. So I make you make $6 per hour. My friend, if I go over to my friend and try to find my slope, find his or her slope, again, it's earnings per hour. So it's dollar per hour is y over x. So I'm going to use my slope formula here, and I come up with 9. I have negative 9 over negative 1 is positive 9. My friend, your friend, makes $9 per hour. So you make $6 per hour, your friend makes $9 per hour. Who has the higher hourly wage? Your friend does. Your friend makes $9 per hour. Write a function that relates your friend's earnings to the number of hours worked. Graph both functions and interpret the graph. So we just figured out that your friend's rate here is $9 per hour. Remember, your rate was $6 per hour. So your friend's rate is $9 per hour, which is the slope. So if we go to write an equation, we can say y equals 9x. Now, we would have to go back and figure out what the y-intercept is for this one. Since they make $9 per hour, 1 hour is $9, 2 hours $18. They're not going to make anything if they work for no hours. Unlike you, take a look at your equation here. If you don't work any hours, 0 times 6 is 0 plus the 12. You're going to make $12 even if you don't actually work. So wherever you're working nicely gives you $12 just for showing up, even if you just go home. So whatever it is that you do, they pay you for getting there to get to that job, and then if you don't actually work anything, you still get 12 hours. I don't know what that job is, but it sounds pretty cool. So they want us to graph both of these functions. So I set up a coordinate plane here so that I could graph both of them to make sure they both fit. For your friend, we already have a table here. So I'm going to graph those ordered pairs, and I come up with this line here. Remember, your friend, 0 hours, no paycheck. You, however, when I go to graph yours, and again, I made myself a quick table here. If you don't work any hours, you make $12. So for no hours, you already start out here with $12, which is kind of nice to start off with. So I made a quick table, and I realized that when I get to 4 hours, you're going to make $36. Your friend also makes $36 at 4 hours. So those two lines meet right here at 4 hours, $36, which is kind of interesting. So you start off making more money because you earned $12 for just showing up because you're so fabulous. But when we get to $36 at 4 hours, your incomes are the same. And then after that, since your friend makes more per hour, your friend starts to do better for each hour after that. So when it says interpret the graphs, I said at 4 hours, you and your friend are both going to earn $36. I could also talk about the fact that after 4 hours, your friend is going to make more, is going to do better for each hour that he works than you are, because your friend is making $9 per hour. So using our real world situations, using an equation, using a table, and interpreting what's happening between these two particular linear functions.